Hi everyone, this is Babaiah, Assistant Professor of ECE Department from MLR Hyderabad. Today I am going to explain about the electrical systems and some of the problems on related electrical systems. Previous class we discussed or we learned from the previous session what are the transfer function model and what is the differential equation models, and also what is meant by Laplace transfer function or else transfer function. All these are learned from the previous sessions. Now let us move on to overview of today's session of the electrical systems examples and some of the problems on electrical systems. Now coming to the electrical systems examples, if any electrical system can be obtained by using the resistor, capacitor and inductor. By using these three, we are going to design any electrical systems. Just here observe, the models of electrical systems can be obtained by using the resistor, capacitor and inductor. These electrical systems can be formed by writing the Kirchhoff current like KCL or else KVL. For KCL, we are going to choose the various nodes. For the KVL, we are going to choose the complete closed path. Here just observe, the electrical system can be formed by writing the Kirchhoff current law equations by choosing the various nodes, as well as in Kirchhoff current voltage law we are going to choose the various closed path in the network. From any network or equivalent circuit, from that we are going to calculate or we are going to write the equations by applying the Kirchhoff voltage law or else Kirchhoff current law based on the, for considering the nodes for the Kirchhoff current law and for the closed path for the network consider for voltage law or Kirchhoff voltage law. Now after that we are going to calculate the transfer function. What we are getting the equations, from that we are going to apply the Laplace transform to the given equations, then we will get the transfer function. Just here observe, the transfer function can be obtained by taking Laplace transform of the differential equations and rearranging them into the output to the input, the ratio of output to the input. That is nothing but the transfer function. Now before going to the problem, just you have to know what are the I equals to and R equals to. For example, I equals V is equal to IR. That the electrical examples or electrical system examples. Just one of the table is there. Here I consider one element. And voltage across resistor and current across resistor, or else here element is the resistor, capacitor, inductor. So here no need to write the resistor. Voltage across element and current across element. Okay, here just observe the symbol, just resistor symbol. Resistor, I of t current flowing through the resistor, and this place negative, and V of t voltage. Now here voltage across the element, voltage across this resistor element, we will get V of t equals to R into I of t, and as well as current across this resistor, element is I of t equals to V of t divided by R, just from here V of t equals to R into I of t. I of t equals to V of t divided by R. Simple. Next here, coming to the next second element is, I'm going to consider the inductor L. Here I of t, current flowing through the inductor. Here voltage across the element V of t equals to L into, here inductor value L into d by dt into I of t, and here current across the element inductor I of t equals to 1 by, this value is differential value, derivative value is going to consider into the integral, like 1 by L into integral of V of t and dt. Next, coming to third element, capacitor. I am going to consider the capacitor C, positive N and negative N. I of t, current flowing through the capacitor. Here V of t is the voltage. Voltage across this capacitor. Here I consider V of t equals to 1 by C into integral I of t into dt. Same as here, just the current across the capacitor is I of t equals to C into d by dt into V of t. This is the basic table for design of any electrical system. For these formulas we are going to use by solving the any problems of related electrical system to calculate the transfer function. Now this is the table of voltage current relation between the resistor, capacitor and inductor. Next, coming to the one example problem, I am going to consider here one example problem. Derive the transfer function. Derive the transfer function of the given electrical system shown in figure. Just I am going to draw the circuit diagram. Resistor, and voltage across the capacitor. I of t. Some example problems, just observe here. Or else directly I consider here voltage V output. Right. Here writing the equation. Now I am going to apply the Kirchhoff laws for the Kirchhoff voltage laws for the given circuit diagram. From that we are going to draw the differential equations of electrical system. Here just observe, writing the differential equations. By applying by applying the KVL for the given circuit. Here observe Vi of t equals to some current flowing like this current. Okay, here Vi of t equals to R into I of t, R into I of t plus, next here C, total output voltage V output of t, and voltage across here V and output of t equals to voltage across the capacitor is here 1 by C integral I of t into dt, right? These two are equations, differential equation. From this, just here I am going to apply the Laplace transform for the two equations. Here just observe, apply the Laplace transform to the above equations. From that we will get V I of s equals to R into I of s plus V naught of or V output of s, and V output of s equals to 1 by sc into I of s. Here just observe, here for apply the Laplace transform for this equation, Vi of t is the Vi of s from t to s domain, and R into I of t, I of s. V output of t is the V out of s, and same here 1 by c, this is here integral term, one integral term is there, so 1 by sc single, 1 by sc, here just observe 1 by sc into I of s. Next from this I of s equals to V naught of s, V output of s into sc, this is the I of s. Now this I of s value substitute in this equation. For example, this equation is 1 and this equation is 2. The equation 2 substitute in equation 1, Vi of s equals to R into V naught of s into sc plus V naught of s. Here just to common the V out, here R is there, R into sc plus 1. The transfer function is nothing but the output. Here observe the circuit diagram. Which one is the output? V naught of t. V naught of t is the output and Vi of t is the input. So the ratio of transfer function is equals to V out of t divided by Vi of t, means V out of s by Vi of s. We are going to calculate this one. So here from that just observe V out of s divided by Vi of s equals to, this term is moving to left side, 1 by R sc plus 1, like this we are going to calculate. For example, I consider t equals to, else I consider the t equals to RC. But RC, substitute this value into this equation, the transfer function V output of s by V input of s equals to 1 by t S or ST plus 1. This is the transfer function of the given electrical system. This is the one of the example problem. Like that, we are going to calculate the any electrical system by using the any KVL, Kirchhoff voltage law or Kirchhoff current law. The two laws are or mesh laws we are going to apply for the any electrical system. From that, we are going to calculate the transfer function. It is in the form of S domain. Same as like that, we are going to do the remaining problems also. Now one more problem. One more problem I am going to explain. The second problem, just observe. Derive the transfer function for the following electrical system. Directly I am going to write the electrical system. For that, we are going to calculate the transfer function. Transfer function for the electrical system. Electrical system, that is, just observe here. Capacitor and resistor, input voltage, and here output voltage, plus minus and plus minus, some current flowing through this. Just here observe. Okay, same we are going to apply the KVL or KVL for the given electrical circuit, and from that we are going to calculate the transfer function by applying the Laplace transform for the differential equations. From this, after apply the any KVL for the given electrical circuit, from that we are going to draw the we are going to write the differential equations. Vi of t equals to 1 by C integral I of t into dt plus R into I of t. This is one equation, and from that second equation, V out of t equals to V naught of t equals to the voltage across current across the resistor is equals to V R into I of t. V equals to R into I of t. This is the second equation. Apply the Laplace transform for these two equations. Laplace transform. Apply Laplace transform for the above equations. Above equations 1 and 2. We will get Vi of s equals to, this one is I is there, so I by I of s by sc plus R into I of s. From this second, V naught of s equals to R into I of s. Now I of s equals to V naught by I of s equals to V naught of s by R. Okay, this is the transfer function for the above electrical circuit. In this session, we learn what are the examples of electrical system, how to calculate the transfer function for the any electrical system by applying the any KVL or KCL. All these are we learn from this today's session. I hope you understand every point. Thank you all.